Hello class, today we are going to talk about the distance formula. But before we actually get into the distance formula, we've got some other stuff we're going to talk about first, some a little bit more basic things. And so you see here that I have a number line drawn on my paper here. I have point A is at -5 and I have point B at 7. And everybody I'm sure feels very, very comfortable with this. You've seen things like this forever. However, is that we need a rule that says we can do that. How do we know that I can put A at -5 and B at 7? You know, some of you think, well, this is obvious. Of course you can do this, right? Well, here's the thing. Geometry is what's referred to as an axiomatic system. That means everything you do, you have to have a rule that says you're allowed to do this. So before I even put point A here and point B at 7, I have to have a rule that says I'm allowed to do that. Fortunately, such a rule does exist, and that rule is called the Euler postulate. So let's write this down. The Euler postulate. What's a postulate? Okay. A postulate, this is a rule that we can't actually definitely prove that it works, but it always has in the past, and we're going to go with it. All right. Think of these kind of like the undefined terms of the geometry rules, okay? Undefined terms, point, lines, plane. We couldn't actually get a very good definition that says this is what it is and this is why this is what it is, but we go with it anyways, okay? Postulates are kind of along that lines. We can't actually have some definite rule that backs up that we can do this, but we're going to go with it, okay? And what the Euler postulate says is that points can be matched to numbers on a number line, and we call those numbers coordinates. All right, so let's write this down. All right, points can be matched with numbers, coordinates, on a number line. And one thing that's very, very important, they are matched 1 to 1. Okay, so if I have A at -5, I can't also have A at 17. All right. And also, if A is at -5, that means C is not also at -5. Only 1 point per coordinate. Okay. So this is great. This is lovely. I can put numbers on a number line. What does that matter? What can I do with that? Well, what I can do with that, since I can have numbers on a number line, that means I can find the distance between those 2 points. All right. I can find the distance from A to B because I can say where A is, and I can say where B is. So I can find the distance between them. All right, and so the distance between 2 points on a number line is equal to the absolute value of the difference of their coordinates. All right. So now a lot of you are thinking, well, yeah, you can just take the difference. You just subtract it and find out what the difference, that's the distance, right? And the thing is, very important, you have to have the absolute value of the distance. Because remember, distance cannot be negative, all right? You can't have a point that is -3 inches from point B, right? I could have 3 inches away and 3 inches away and 3 inches away and 3 inches away. I could be 3 inches above it. I could be 3 inches below it down under my desk, but I can't be -3 inches from point B. So it's going to always be the absolute value of the difference because we have to have a positive number. All right, so what this means, what can we do with this? Okay, so what we have here, we have AB. That is a terrible color for this. Let me just throw that over there. Let's grab this one. All right. AB equals the absolute value of -5 minus 7. Right? Notice, real quickly, I did not put any kind of symbol above AB. Okay? There is no symbol here. So if I have no symbol, that means I'm not talking about segment AB, I'm not talking about line AB, I'm not talking about ray AB. No symbol here means that what I am talking about is length. I want to know the distance from A to B. This is the length of segment AB. So the length of segment AB, the distance from A to B, is equal to, let's see, -5 minus 7, that would be -12, but the absolute value means to make it positive. So the length of AB is 12. All right? So that's pretty easy stuff, not a big deal. Okay, so let's do this. Something a little bit different. Let's come down here. I'm going to draw another number line. I'm going to put point A here. I'm going to put point B there. I'm going to put point C right there. And instead of giving coordinates, I'm just going to skip that. I'm just going to talk about the length here. So I'm going to say that this is 7 units and this is 3 units. Okay? And if I want to know the length of segment AC, well, that's real easy. I know how to do that. But again, it's an axiomatic system. It's based on rules. We have to have a rule that says how to find this. And that rule is the segment addition postulate. So here we go. The segment addition postulate. And what this says is that if B is between A and C, then we can add these two up. All right? So, if B is between A and C, then AB plus the length of BC is equal to the length of AC. Once again, I want to point out that right here, I have no symbol, so we're talking about length. No symbol there means length or distance, either way. The distance from A to B. So what we have, the length of AB, well, how long is AB? I wrote it right there, that's 7. Plus the length of BC, 3. And that is going to equal the length of AC, and so the length of AC is equal to 10 units. All right? And so this brings us to the distance formula. And the distance formula, as you see, is fairly ugly. We have x2 minus x1 squared plus y2 minus y1 squared, and then we take the square root of the entire thing, right? What this is for, this is if I'm not on one number line, if I'm on 2 number lines, if I'm on a coordinate grid where I don't have just the x-axis, but I also have a y-axis as well, like this right here, okay? So if you have 2 axes, you got going like this, going across, it's not going right along one number line, no, right along the other line. It's going at an angle. And you can't just count that over. You can't just, it's annoying. It's hard to do. So what we have, well, it's not hard, but whatever, is this formula that's going to help us out. So what we have right here, so this x2 minus x1, what that is this distance right here. Okay, x2 minus x1. And then we have y2 minus y1, which is going to be this distance right there, y2 minus y1. And if you'll notice, what this really does is this turns into Pythagorean theorem, right? Where I have this is A, and this is B. And so Pythagorean theorem, you have a squared plus b squared equals c squared. Well, I'm not interested in a squared plus b. I'm not interested in c squared. I'm interested in d, right? So I'm just interested in c. And so we have is d is equal to the square root of a squared plus b squared. Just another way to think about it. Kind of makes it a little bit easier sometimes, if you have a grid. If you've got a coordinate grid, you can do it like that, and it's basically just Pythagorean theorem. If you don't have a coordinate grid, use the formula. And that's what we're going to do here. We're going to use the formula. Example 1, we want to find the distance from point 4, -6 to the point 0, 3. And I don't want to use this one. All right. So I've got 2 points. I'm going to label my x1 and x2 and y1 and y2 and all that. So this is my first point because it's listed first. It doesn't really matter. So I'm going to call this x1, and this would be y1. So this is x2, and this would be y2. And I'm just going to plug them into the formula. So my distance is equal to the square root of x2, so 0, minus x1, 4, squared, plus y2, 3, plus y1, which is, that's minus y1, which is negative 6, squared. All right, so my distance is the square root of, 0 minus 4, because parentheses come first, right? Start from the inside, work your way out. 0 minus 4 is negative 4 squared plus 3 minus negative 6. Remember, we're subtracting, so it's adding the opposite. So 3 plus positive 6, 9 squared. All right, so my distance is the square root of negative 4 squared. Negative 4 times negative 4 is positive 16 plus 9 squared, which is 81. And so my distance is equal to the square root of 97. That's not very pretty or anything, but I don't have a calculator to come up with the actual decimal. The decimal's ugly anyways. It's going to go on forever and ever and ever because that's not a perfect square. And I would like to simplify it, but 97 is prime, so it's not going to simplify. That's my answer right there. All right? Okay. So what I would like for you to do, pause the video and work out example number 2 there. All right? Work that out, see what you get, and then come back and see how you did. All right, so you're back. Let's take a look. So we need the distance between negative 4, 2 and 0, negative 8. So we set up our distance formula. D is equal to the square root of, well, let's see. You know what? This time, just so we can see this, I'm going to use this as 0.1 and that as 0.2. So this is going to be x1 and y1. This is x2 and y2. So let's see here. Negative 4 is my x2. So negative 4 minus x1, which is 0, squared, plus y2, that's y2, not 1/2, of 2 minus negative 8 squared. I was getting ahead of myself. And now let's work this out. So d is the square root of negative 4 minus 0. Well, minus 0, that doesn't do anything. So that would be negative 4 squared plus 8 minus negative, 2 minus negative 8. Again, add the opposite, so that turns into plus 8. So this is 10 squared. So d is equal to the square root of, let's see, negative 4 squared, that's 16 again, same thing we had a minute ago. And 10 squared is 100. Add that up. And d is equal to the square root of 116. Again, that's not a pretty square root, so it would be decimal, so we'd rather leave it as a square root, but we do want to simplify it if we can. And this one will simplify. And we'll simplify this one off to the side over here. So we start with the square root of 116, and we do our factor trees, right? So let's see, factors of 116. Well, it's even, so I could use 2, right? Because 6 is even. But if you look at this, my last 2 digits, 16, that's a multiple of 4, right? 16 is divisible by 4, which means the entire thing is divisible by 4. And that's a little bit bigger than 2, so let's go with that. So 4 goes into 1, it doesn't. 4 goes into 11 twice, leaving me 3. And so I've got 36, 4 goes into 36 9 times. So 4 and 29. So let's see, 4 is a perfect square, so the square root of 4 is 2, out from under the square root. 29 is prime, so that's done. So that means my answer is going to be 2 square roots of 29. And there it is, simplified. And this is distance formula. If you have numbers on a number line, so it's just a single number line, all you have to do is take the 2 coordinates, subtract them, and take the absolute value. So you have a positive number. And this is distance, and that's ruler postulate. All right. If, on the other hand, you have two segments, as long as B is in between the other two, you can add them up. That's very important. If B was out here, say I had point D way out here, and this is 8 and that is 4, I can't add it up and figure out the distance going across. That doesn't work, right? Because you're cutting a corner. It's going to be shorter. Right? B has to be in between. They have to be collinear. And if they are, then you can just add the two segments up. If you have two number lines, so you're on a coordinate grid, then you have to do the distance formula, which is really nothing more than Pythagorean theorem. All right. Please do simplify your square roots. Makes it a lot better. All right. And there you go. Hopefully you found that useful, and I will see you in the next video.